section 7.4 is evaluating logarithms and logarithmic functions, and this will for sure stretch your mind. So I would, push pause when you need to, or rewind when you need to re-listen to something, and make sure that you really understand these concepts before moving on. So the first thing I just want to cover, of course, is some vocabulary. So what in the world is a logarithm? A logarithm, and first of all, it's denoted by the following notation, and you would read that log base b of y, and we define it as log base b of y equals x if and only if b to the x equals y. And then just some sidebar notes here, given that b and y are both positive numbers and that b can't equal 1. And I want you to think about this in terms of stuff you know, okay? You know b to the x equals y, that's an exponential function. Okay, you know also that b has to be positive to be a growth or decay function. If you make b negative, it's a reflection of a growth or a reflection of a decay function. So we want to keep b positive so that it's either growth or decay. We also know that b can't be 1, because if you have a base of 1 and you raise 1 to various values of x, it's not going to change, hence it's not an exponential function. So because of that, okay, stuff you already should know about that equation, now just note that a logarithm is another way to write an exponential function. So the base of the exponential function is the base of your logarithmic function, and then it's as if the x and the y switch. So you see here how the b and the x are connected. With a log, it's just the opposite. The base b and the y are connected. So you're going to take log base b of y equals x. And we're going to do several problems going back and forth between these, and I think you'll get it down no problem. Two logarithms that you're going to want to be familiar with both for terminology and on your calculator are the common logarithm, and that's a logarithm that has a base of 10. So the base would be written like this, so log base 10. However, you don't ever see that base, so like if you see just log in your textbook, which you will, you assume that's a base of 10. So you don't actually write the base of 10, and that's why it's called common, because it's so prevalent. The natural logarithm, you should recognize base of e, is just like writing log base e. However, again, you don't write the e, and you don't use log typically, although log base e is the same as the natural log, which is ln. So again, the natural log has a base of e, but you're never going to see that there, so you have to become comfortable with that natural log as ln, and you won't see the base e, although that's its base. Just real quickly, make sure you can find this on your calculator. So if you have an 83 or an 84, and I know my calculators are kind of small here, but your log button is right to the left of 7, and your natural log button is right to the left of 4. So log and ln, those are your log and natural log buttons. 89's, your natural log button is, of course now it's so small, it's in blue above x. And your log button is actually a hidden key, and I believe it's diamond 7. So your green key, and then 7. So let me write that down, 89. So you're going to do your green button or diamond 7, and that should give you your log button. So pause this, make sure you can find it, play around with it. So we already talked about the definition of a logarithm, but it's important, so just kind of remind yourself that log base b of y equals x if and only if y equals b to the x. So taking this exponential function and write it in logarithmic form, or vice versa, take a log and write it in exponential form. So they are the same. So, and again, how do you read this? Log base b of y is how you read that expression. So a couple examples of going back and forth. So if you have something in logarithmic form, so I'm going to start with this first one here, it says log base 2 of 32 equals 5. So we're going to go to exponential form. So we're going to go from log to exponential form. And note that the base of this 2, the base of the log is 2, so that means the base of your exponent is 2. And then if you recall, whatever's with the log, the base of the log, which happens to be a 32, is not with the base in exponential form. So it's going to equal 32, and then the equals 5 becomes your exponent. And then, of course, you can double check, is 2 to the 5th equal to 32? And certainly it is. Second one here, log base 7 of 1 equals 0. So again, the base of my log is 7, so then the base of my exponential function is also 7. And then the 1 and the 0 flip. So if the 1 is with the log, it becomes what the exponential function equals, and the equals 0 becomes the power of my exponent, and yes, 7 to the 0 equals 1. Just take a second, pause the video, see if you can do the next two real quickly, and then I will write the answers. So third one says log base 13 of 13 equals 1. So 13 to the first equals 13, which of course is true. And last one, log base 1/2 of 2 equals -1. So that would be 1/2 to the -1 power equals 2. And yes, it does. Last but not least, you'll be asked to evaluate logarithms, and this will be without your calculator. Eventually you'll know how to do these with your calculator also, but for now, understand you'll also have to do them without. So, log base 3 of 81, I want to know what that is, and keep in mind that a log is really just another way of writing an exponent. So log base 3 of 81 is really just a number, which I know it looks funny with words, and a word in there, log, that it would actually just be a number. So I always set these equal to x or some variable, and I want to know what that equals. And then I know I can just go to exponential form. So if the base of my log is 3, the base of my exponent is 3. And then what it equals is x, and that's what I'm about to find out. And then that should equal 81, because the log base 3 of 81 in exponential form would equal 81. And now it's probably pretty easy to see that 3 to the 4th is 81. So I know that this log base 3 of 81, actually let me erase that, is just going to equal 4, because 3 to the 4th equals 81. Let's look at another one. If you look at B, it says log base 4 of 0.25, and I want to know what that equals. And again, right now, I don't know what that equals. So the base of my log is 4. That means the base of my exponent would be 4. It equals x, so that's going to be the power. And I'm taking the log of 0.25. So 4 to the what equals 0.25? And if it's easier, in fact, I'm going to do this. If it's easier to think of 0.25 as a fraction, that's 1/4, then it might be easier to see that 4 to the -1 equals 1/4, because of course anything to a negative exponent flips. So I now know that log base 4 of 0.25 is really just -1. Cool. So again, I would highly recommend if you pause the video right now and try C and D, make yourself think about it, and then I'll write the answers. So C says log base 1/4 of 256. So that would be 1/4 to the what power equals 256. Well, 4 to the 4th power is 256, but it's 1/4, and it's a base of 1/4 and not 4. So if 4 to the 4th is 256, then I know I want to raise it to a negative exponent so that this is really flipping, so that is really going to be equal to -4. And last but not least, log base 49 of 7, so 49 to the what power equals 7. Well, I know the square root of 49 is 7, and the square root as a power is 1/2. So 49 to the 1/2 would equal 7.